Hi folks, we're going to take a look at page 111, number 10. So let's take a look at this question here. It says the width of a square-based storage tank is 3 meters less than its height, and the tank has a capacity of 20 meters cubed. And they specifically say that the dimensions have to be integer values. They want to know what the dimensions are. So since it's a box, we've got length, width, and height. It's a square-based box, so that means the length and width on the base are going to be the same. Okay, and they give us a relationship between the height and the dimensions at the base. Okay, so tell us here that the width of the base is 3 meters less. So with that, we hopefully can come up with an equation to solve. And in order to do that, since I'm working with a physical situation, I'm going to start by drawing a diagram. Okay, so let's start by drawing some generic box. Okay. Now, it just tells us that the base is a square. Okay, so we can't assume that the height, in fact, we know the height's not going to be the same because they give us a relationship. Okay, and so I also have to deal with the height, and then here I've got my base values. Okay, but they're saying that the width of the base is 3 meters less than the height. So if I call the height x, this is just going to be the height minus 3. And since it's square-based, so will this dimension be the height minus 3. Okay, so what we have now is we have a representation of all three dimensions, and then from there they give us information about the capacity, and capacity has to do with volume. So what's the volume we could fit into this box, and they tell us that it's 20 meters cubed. Okay, so of course we know that the volume of rectangular prism is base times length times height. Okay, here they tell us that the volume can be up to 20 meters cubed. Okay, base and length are the same, so we have x minus 3 squared, and then times the height, which we called x. And what we have here is a polynomial equation. Now we have a cubic polynomial equation because when I square this and then multiply it by x, I'm going to end up with a cubic, and so I'm going to follow my procedure for solving a polynomial equation. So first thing is to bring everything to the other side, so I'll bring the 20 over to the right-hand side. I'm going to have to do some expanding here because while the right-hand side is in factored form, once I bring the 20 to the other side, it won't be factored anymore. So we're going to have to expand everything, and then hopefully we'll be able to refactor it again. So here, x minus 3 squared is x squared minus 6x plus 9, okay, times x. And then here we have the minus 20, and let's simplify that even further. So distribute the x, we have x cubed minus 6x squared plus 9x minus 20. And this is our more familiar form. Okay, so I take a quick look to see if this can be factored by grouping, and that's not looking like it's going to happen. Okay, so again, let's give this a name. Let's call this f at x, and let's start testing out our factors of 20. We only have to worry about 20 because the leading coefficient is 1. So this is where we start, f at 1. Okay, 1 minus 6 is negative 5. Plus 9, well, I can already see once I subtract the 20, that's not going to be equal to 0. So let's go to f at negative 1. Now, notice here, x can't actually be equal to negative 1 because we're talking about dimensions here. You can't have a height of negative 1. But remember, all I'm trying to do is to factor this. So it could be that x plus 1 is a factor. Then from the other factor, I might get some positive integer roots. Okay, so we'll still try it out here. So here, this is going to be negative 1 minus 6 is negative 7. This is going to be minus 9 and then minus 20. So clearly that's not going to be equal to 0. So let's move to f at 2. And even though I probably could manage to do this in my head, I think I'm just going to take the calculator just to make sure I don't make any silly mistakes. Okay, so let's take a look at what we have. So we have 2 cubed. Oops, start again. 2 cubed minus 6 times 2 squared plus 9 times 2 minus 20. Okay, not equal to 0. So let's try f at negative 2. Okay, so this is going to be negative 2 cubed, okay, minus 6 times, well, negative 2 squared is going to be 4, so to avoid having to use brackets, I was able to do that in my head, so times 4. Then this is going to end up being a subtraction since it's a negative number, so minus 9 times 2 is 18, and then minus 20, and that is not 0. Okay, let's move on to the next one. Let's put in 4. So f at 4, let's hope this works. So 4 cubed minus 6 times 4 squared is 16, plus 9 times 4 minus 20, and that's not equal to 0. So this is a bit of an annoying one. I guess let's try negative 4 for good measure. So that's going to be negative 4 cubed, so negative 64 minus 6 times negative 4 squared is going to be 16. This is going to be minus 9 times 4 because x is negative, and then minus 20, and something tells me that wasn't going to work. So I hope we don't get to 20, although I think you can imagine that's actually impossible. So let's hope 5 does the trick. Let's see what happens. 5 cubed minus 6 times 5 squared is 25, plus 9 times 5 minus 20. Let's hope that works. And there you go, 0. Perfect, finally. So this was a bit of an annoying one, but hey, you just go through them, okay? You try to do it as quickly as you can. So now, what we have is that x minus 5 is a factor, okay? And so I'm just going to divide out x minus 5 from this polynomial here. So I'm going to use synthetic division. We'll go to this side. So we have 1, negative 6, 9, and negative 20. And divide that by x minus 5. So 5 is our representative for that. So we got 1, 5, negative 6 plus 5 is negative 1. That's going to be negative 5. 9 minus 5 is 4. And here 20, and we do get a remainder of 0. Okay, so finally after all that, I can rewrite the right-hand side as x minus 5 times, and these are coefficients of the quadratic, x squared minus x plus 4. Okay, and I look at this quadratic left over, and this does not look factorable at all. And in fact, if we put it into b squared minus 4ac, if we check the discriminant, we see that we have b squared, so negative 1 squared is 1, minus 4 times 1 times 4. Not only is it not going to be an integer, okay, it's not even going to be a real number. So in fact, in the end, x equals 5 is our only 0 and also our only integer 0. Okay, so that tells us that x equals 5 solves this equation. So let's go back. I'm going to take a look at the question and see what are they actually asking me for. And it's saying to find all the dimensions. Okay, so what does this mean? X just represented the height. So we have a height of, and I'm going to assume this is in meters cubed. Yeah, so that means the height is going to be 5 meters. Okay, and then the base width, okay, which represents both the length and width of this box, is just going to be, sorry, that's width, there we go, is just going to be equal to 5 minus 3, 2 meters. Okay, so the dimensions of this box, if we want to write it out in that way, are 2 meters by 2 meters by 5 meters. Although this above would be fine because you've specified all the important dimensions. Okay, so that's it for this one, but let's take a quick recap. So number 1, notice how I used a diagram. Physical situation, draw a diagram to represent the scenario. Okay, from there I was able to use my properties of measurement, in this case here volume of rectangular prism, to set up an equation which turned out to be a polynomial equation which I solved with the methods we've used in this chapter. Okay, that's it.